Okay, so thank you very much for being here. This is our last webinar, or maybe there is someone else that can enter. Okay. Hello. This is the last webinar from our session, and in the last webinars we knew all the projects involved in this series, their objectives and their use cases. So now in this call we will take a deep into the lesson learned. The projects involved are always AutoTwin, Da Capo, DCIM, and Restore. During this session, we will showcase how each project overcome barriers and challenges, the problem-solving strategies, and the social impact of their methodologies of circular approach. We will focus also on the value of knowledge exchange between us. So if there is some solution or methodologies that have inspired improvements between our projects, and if it is the possibilities of new opportunities and collaboration. Okay, yes, the webinars are organized by Syxis. And so now we can start. The order will be first of all AutoTwin project, then Da Capo, DCIM, and Restore. As always, you can write down the questions and comments in the section question and answer, and then we will read them at the end of the session during which we can also discuss together and as some questions. So thank you. We can start with AutoTwin. So please, Dario, you can start with your presentation. Thank you.
Can you see my presentation?
Yes.
Okay, so good morning. I'm Dario Pietraroia from Technology Transfer System. We are one of the partners of the AutoTwin project, mostly one of the technical partners. So speaking about the lesson learned today will be more on the technical side. So I hope some insight will be appreciated. So small recap, we already know the project. It was a research innovation action project, and we have 13 construction numbers, 8 countries involved. We are now at the moment, you can see we have 36 months of project. Now we are at month 33. So we are mostly in the end phase of the project. The partner I already know, there are some academic partners, and mainly 3 use cases, just to refresh a little bit, because I will speak about specific lessons learned in specific use cases, are Croma Jobatta, which it's surgical instrument sterilization in Burgos, Spain. I mean, it's a company, big company, but the use case was in Burgos, specifically the hospital of Burgos. Libation, which is a battery recycling company in Switzerland, and Green, which is a plastic recycling company, in the sense that they reduce plastic to the original polymers to obtain completely virgin PET. The idea was starting from data, create model and insight from this data, and help with digital twin models, data analysis tools to help to support the green decisions in circular economies. Currently, as I said, the project is at month 33, so all the pilots are in the final deployment stage. We will have the last general assembly next week. And each instance of the platform have been deployed for each pilot. And the digital twins that we developed are undergoing the last validation phase. Not exactly for one pilot, but I will speak about that later. So what we achieved so far, we have now a robust and methodological framework for data-driven digital twins building, and especially with the focus on green decisions. So we have a framework to which will be the KPI, the indicators, what we call the green gateways. So the point in which we can, with the decision inside the process or during the circular value chain, influence the output, the ecological and green impact of the process. And we are focused on creating tools which help in the decision in this turning point. We obtain, this is, I think, a fair, good technical result. We have an integrated platform which applies different algorithms and tools on an up-to-date central data repository. So we are available when we deploy the AutoTwin platform to have an updated database coming from the real system. And all the tools share the same base. So it's a fairly technical advantage to have all the tool of the tool chain, also the different aspect, learning models, digital twin generation, process monitoring, coming all from the same database. And we have an automated tool chain to generate, calibrate, and execute digital twin on the platform. We had some pilot-specific issues, and once was because I will focus a little bit on these lessons learned on data. Why? Because of course I think that whole of the project of this cluster are data-driven projects, and I think that one big lesson learned it's about quality and processing of data, because in the case of the Chroma pilot, it was a very tracked process. It's a medical device sterilization, so they came to us and said, okay, we have a lot of data because we have to track everything. We need for certification purposes and so on to know which operator sterilized a certain batch of instruments. But what we learned from that is that even if the database is very large, the data are not specific for process tracking. And so it was sometimes difficult from this data to extract data about process. And the solution was to integrate with what we call the domain knowledge data. So knowledge which comes from people who know the process. The difficult part in this is that domain knowledge data are not usually standardized, and it's difficult because that tracking during a process are usually time series data. They're very standardized. We know something is moving into a certain point, to a certain process, and we are able from this data to reconstruct the process. But domain knowledge is something that is difficult to standardize. So we have had to find some ways to introduce this, which is in the end the value added, which can be added to every application of the AutoTwin project. Then we have the green pilot. That was a very nice use case, circular value chain of plastic, automatic plant with a lot of sensor. Since it was also an experimental, it was also on using the words of people of green and the guy who designed the plant. It was over sensorized just because it was an experimental plant. What was the problem? It's an experimental system. experimental system didn't have large chains of events registered of the whole plant working. So it was difficult for us to mine a model of the process for the whole plant. And also, data came a little bit later than we expected due to technical problems. They were still building the plant when the project started, and as you know, when you go near the machines, you go near production, there are always some delays in building. But the solution was simulation of different subsystems of the plant. So we added this function. The case also of the Libation pilot was an interesting case, because when we visited them, I was involved. I'm very involved in the digital twin, automatic digital twin generation part, and also in the pilot specification at the beginning of the project as a partner. So we realized that there were not a lot of data available about the process. The project. It's a mistake. I meant the process, not project. And so what was the outcome? And also the focus changed. It was a startup, also in this case, not an established company. So they changed the product on the way. We focused on a different one. So how we solved this? We developed, instead of the digital twin of the process, we developed a digital twin of the product. So the product now, it's a battery storage system made with recycled batteries. So they have storage racks to put into facilities to act as a storage system for renewable energies and so on. So what was interesting in, we turned, I come from industrial engineering, they always say, turn problems into occasions, okay? And what we did is, okay, we can also process different type of digital twins, not only process digital twins. So what are we doing here in Libation? We are not supporting in optimizing the process, but we are supporting in having a model of the battery to improve the maintenance process, the battery monitoring, and so to minimize returns and technical intervention and optimize technical intervention. What about social acceptance and impacts of this process? As usual, speaking about data, users are worried about a lot about data security. That's always a point to take in point. So sometimes we had to deal with where the solution is deployed, how we treat data, how data spaces are involved, since we have also a data spaces part, which of course it's about securely sharing data only which wants to. So it's interesting. And this is more about, in general, it's about SMEs in general. When you involve them into projects, sometimes they're not fully aware on what problem they want to solve. So they just say, okay, we have data, this is the process, help us improving. And it's not a fair input. Of course, for research purposes, it could be interesting, but it's sometimes difficult to build a robust use case on this. So what lessons we learn and which could be the future improvements? So about data quality and availability, data-driven projects, I talked about two opposite approaches. From one side, guidelines for creating some, I mean, it's also something which I experienced a lot, and I built a lot of digital twins and simulation models in industry. So dealing with non-standardized data, even if we are in a era of, it could seem a little bit counterintuitive, these lessons learned that I'm thinking about, because, okay, we are in the era of big data. We have always a lot of data improving, but especially because of SMEs, quality of data, it's still a problem. So we could have to approach guidelines for creating data logs for process mining. So if we want to organize process mining, we could have guidelines. But this is not always simple. On the other side, we are in the era of AI. So maybe that we could leverage AI once to generate synthetic data to better train process mining models. And on another side, to deal with unstructured data, because nowadays AI models are very good in dealing with unstructured data, natural language, and so on. So maybe that this can help to create a more structured database. And project-wise, it's just maybe quite a personal opinion to build solid use cases in projects, because sometimes applying on the pilots, of course, this was a research project, we are a research innovation object, so it was applied, but with not a complete TRL of 6, 7 for most of the components, and the results are good, but the quality of the results greatly depended on the data and on how the idea of using the digital twin to improve the green aspects and also the circular value chain was perceived by the end user. So I hope it was I gave some hint on the lesson learned that could be beneficial for all the projects. So I look forward to hear your presentations.
Thank you. Thank you. Yes, it was very, very good and very specific presentation. So now let's see if the other projects are having the similar problems or something else. So let's continue with the other project, so the Capo project. Thank you.
Yes, so good morning, everyone. My name is Filipa, and I am from AIMEN, and we are the project coordinators for Da Capo. I hope you can see my screen.
Yes. Perfect.
And okay, perfect. So I'll be presenting a bit the Da Capo project and the main lessons learned. So just a short project recap. The Da Capo project aims to creating human-centric digital tools to improve the adoption of circular economy strategies that go through the entire product life cycle, from design and manufacturing to the use phase and end of life. So we are developing new digital assets and digital twins for processes and products, developing also a digital product passport and the circular economy decision support system to facilitate trusted data exchange and optimize circular strategies. Also creating a modular digital thread concept to normalize and orchestrate all data. We are a consortium of 15 partners spanned by 10 countries. And we have the 3 use cases on 3 critical EU value chains, so aeronautics, electronics, and logistics. And currently we are at month 33 of the project, so at an advanced stage as well. And we are just actually starting with the pilots proving all the tools on the pilots. So I would say that the 3 main lessons learned that we have so far regards one of the things that Dario also mentioned regarding the kind of the data gap, where we see that it's just not a lack of data, but issues with quality and confidentiality of data, where our partners somehow also are very reluctant sometimes to share sensitive information, which is totally understandable. Also, we faced issues with the storyline for the use cases. I guess that somehow we might be naive thinking that we can start right ahead with our tool, but we learned that we really have to develop the tools and the technology based on a well-defined narrative. So the first step is really the story on how technology will solve a real user's problem. And we had that issue at the beginning of the project. And how also another lesson on how the data structure must be adaptive. So we really are focusing on specific data of a use case, and then from that propose a generic structure that is flexible enough for other scenarios. So talking about the main strategies that we used, so we promote open data and collaboration to mitigate all these confidentiality issues and the data gap. We promote open data sets so that we don't have these issues with the sensitivity of data. Also, we, as I said, another strategy from ours was to really start from the storyline. So we focused on co-creating these workshops with the end users to validate the use case stories. And this was kind of an interactive process, since at the beginning we needed to usually come back to this and redo meetings and workshops to really have a clear story of the use case. And also to have an iterative data structure optimization. So tackling the data structures very iteratively, starting with a small specific data set for one use case and progressively refining the structure with reaching more data. Regarding the social acceptance and impacts of the project, we really have a user-centric approach. We are placing the humans at the center of the digital transformation and committed with this user experience and human-centric approach. So we are using, for example, extended reality to help workers with inspection and maintenance of products, and really hope to have an impact there. Also regarding the economic impact, with the project, we really believe that we are creating tools that will help reduce the production and maintenance costs and increasing the overall efficiency. And of course, with our circularity project, we are reducing material waste, energy consumption, increasing circularity, and contributing for more sustainable production. Regarding the cross-project synergies and inspiration, we, as a synergy, we may have this shared data platform. The development of the Capo platform can be adapted for other industries, and which will be one of the goals at the end, and can serve as a model for future projects aiming to digitize the traditional industries and having this type of collaboration between academia and industry as essential for success. For common ground for future collaboration, we are open to creating this data standard. The biggest barrier, as we see, is a lack of standardization. So this future collaboration is imperative. The focus on the human skills, as we are doing already, and promoting also training information to workers, and the use of OpenAI platforms to promote the development of OpenAI sources and so on. Regarding the next steps of the project, as I said, we are at the crucial final steps on month 33. We are finalizing the implementation at the use case, validating all the tools. We are just starting on that task, and we aim at developing new AI modules, focusing on covering unexplored areas in manufacturing, and always disseminate all of our results and increase the promotion of these tools. And I hope this was not too short and that it could give a good overview of the project and our lessons learned. And if any doubts or questions come up, I'm happy to reply and also give any feedback on this.
Yes, thank you. Yes, thank you. Well, maybe after all the presentation, we can discuss about some new collaboration and exchange ideas. Thank you. So we can go on with the third project, DCIM.
Okay, so we split the presentation. I will cover the first few slides, and then Miha will continue because he's the expert on artificial intelligence and other stuff with it. I'm just the talker about conceptual and general stuff. So we develop mainly digital solutions to support circular economy. And Miha, if you can switch to the next slide. And our objective is develop a digital platform which is integrated with digital solution, mainly IoT, AI, big data, and AR. And in this presentation, we will focus on lessons learned with AI implementation because it helps with support, decision-making, and value recovery activities. So next, please. So to recap the use cases, we have 4 use cases, which is Archelix refrigerators, Lexmark printers, Gorenjes washing machines, and logistics and inspection for the automotive parts of CIECO. However, we will focus only on one use case in this presentation. And just also to recap the technology. So as I said, we focus on developing AI, IoT, image processing, AR, and solutions. But here in this presentation, we will focus on lessons learned on AI implementation. So next, please. The case is Gorenjes, a business unit focusing on white goods, especially washing machine. So before the start project of the project, they had limited tracking, tracing, and condition monitoring capabilities of the washing machines. So one part is to enhance this part with IoT capabilities. However, they also need, or they had lack of decision support to manage the reverse flows, assessing the condition of the returned washing machines. And this is connected to how and which critical parts of washing machines should and could be recovered. The process of recovering the critical parts is prone to errors. For example, they can recover a critical part that will fail very soon, or they will maybe omit recovering a part that is that has a good condition, but they think that it doesn't have a good condition. And for all of this, artificial intelligence application is really helpful because it can help them to support their decision making about optimizing not only reverse logistics flows, but improve the spare parts availability as they can recover it from the returned washing machines. And I believe now it's Miha's part, and he will explain to you about the strategy and all lessons learned and solutions we developed.
Yes, thank you, Michal. So I will take over here on, so as mentioned before, very specific one use case, which is the washing machines. So to explain what we had in terms of data availability, so within the DCIM project, so the IoT capabilities, so the sensors, the stream of data, and so on was enhanced, and we had that enhanced IoT data stream put on the line roughly 1 year ago. And for that matter, we had a separate records of aftermarket interventions. So here I'm referring to service interventions, maintenance that is done by the technicians from Gorenje. And the first strategy or the first point was, so let's focus on three components within the washing machine and try to assess the condition of these components. And let's use both of those data sources. And the goals were roughly three. So increase the appliance uptime, optimize reverse flows when there is the end of use phase, and then the support decision making in value recovery at the end of life of these three components. And we decided for two reasons. So one is, as Dario explained before, so let's have a hybrid complementary data sources. So some is AI, IoT, data-driven stuff, and the other is domain knowledge data that we need. So, but in terms of reverse logistics and value recovery, there is also some sensitive data involvement. So personal user data that is under so many legal considerations. So we try to differentiate between the tools that use that data and the tools that only apply or work with technical data. And as I said, so the main focus was on the washing machine components, and I will try to explain, as this is the presentation on lessons learned, one of the failed attempts. So one of the things that seemed quite straightforward when we went into the project was, let's develop an AI model that will be using IoT data as features, as inputs, and we will make labels from aftermarket records. So for example, we have a washing machine. If I just skip one slide back. So for example, if you select a certain setting of washing cycle, certain temperature and spin and so on, and if you load the machine with a certain amount of clothes, so all of the three components listed here will have a different operational regime. So heater will work for different amounts of time, pump will work at different times for different amounts of time, and also motor will consume. So energy consumption of the motor will be significantly different. And so basically none of the cycles in the washing machine during the lifetime is completely repeatable. So it's hard to say what is the normal operation of this. But the first iteration was, so let's monitor the IoT data from each cycle, and let's try to relate them with the aftermarket records if we have some certain things that are useful. For example, in the cycle 1000, the heater was replaced. In cycle something, the towel bearings were destroyed. So let's try to relate these labels in aftermarket with the IoT data and predict the failures that will happen. In that attempt, we failed very hard. So there are two main challenges. So the first is that we just developed a new generation of machines and launched into the market, which resulted in the fact that actually there was a very few relevant failures in the market machines. And this was simply not a sufficient basis for a supervised AI model training. And another very important point is that even if you have enough of aftermarket data, and there was another problem that these were a completely separate databases that it was hard to match them. So the technician notes and also operations done in the interventions are very inconsistent and very subjective. So it's very hard to use such data for training of the AI models. So this is why we went into another, maybe more appropriate strategy path. So in the iteration 2, we went to the AI-driven anomaly detection, and we completely omitted the service intervention logs because it was simply not applicable for the certain for the given data conditions. And we went to the strategy where we were dealing with the new generations of washing machines that were mainly doing maybe less than one year of washing cycles. So let's use a subset of this part in the year, and let's call first 100 cycles in the washing machine. This is a nominal operation. This is as new condition, and this is what is normal. So this is normal, and let's monitor these things, or let's train the AI model to be able to predict what is a normal operational status for 3 components for a given settings and loads of a washing cycle. And in the mid-use phase of the washing machine, this can be used to simply compare the prediction of the normal nominal operation at the cycle and the actual monitored parameters from the IoT data stream, and simply compare, so is the deviation big or small? And after, so for some cycle, if I zoom in, you can simply predict. So there are significant deviations or there are small deviations for certain component. And so if there is a small deviation, it's a good chance that the component is still in good condition. If deviations are consistently great or significant, so something is wrong with the component, or there are some anomalies, do not proceed with the reuse or refurbishment of that component, or at least do not directly reuse it as a spare part or something like that. So this was very roughly explain the final solution strategy. And apart from that, as this is hardly interpretable for service technicians and so on, we developed 2 additional tools that are not so strictly AI driven, but they also, as I mentioned before, accept expert/sensitive information, and those tools can be run internally at the company, not in the open access platforms and stuff like that, which is often envisioned in EU-funded projects. And the one tool is for the reverse logistics. So apart from AI estimation of health, we also take parameters on demand, location of the device, locations of the refurbishment and disposal centers, and we provide the estimation of optimal reverse routing for the machines to be returned to a facility for value recovery. And for the end-of-life strategy, so we use health prediction from the AI model and also some other parameters, including expert-guided variables from the company, which have the domain knowledge, and they will determine the component then finally if it goes to refurbishment, reuse, or recycling, or they can use it as a spare part in the end. So if I just showcase the user outputs for the technicians, so we have developed an interactive GUI, so graphical user interface, to provide technicians with component and system level health assessment. So they just have to put in the machine ID, and they had the results visualized in a user-friendly interface. So if the component is in bad shape, this will be colored in red. If it's in good shape, it will be colored in green, and so on. And they get some recent component history also displayed here. And for the graphical routing tool, so we have an open source tool that determines the shortest path for the recycling routing or the recovery routing, considering also geography, facility, and availability. Apart from the health, we are still in the final phases of implementing these decisions with demonstrators. For us is also month 33 out of 4 years. So these are the final stages. Maybe if I outline the challenges that we had, I opted to specifically mention 3. So one thing with the washing machines was that we really had a very early maturity of the IoT data, which means that even if the streams of the data were enriched, so they were untested, inconsistently recorded, we had no boundaries for start of end of washing cycle, misaligned time steps, so whatnot. Apart from that, we also had a sparse and fragmented records of the aftermarket record service interventions. So there were very few devices with the latest firmware, so there were no long histories, and service logs were sparse, unsynced, and specifically, even if not written here, subjective, so couldn't be used. But we had a bit of so I won't just say luck, but also great experience. So the 2 things helped to mitigate the issues. One was the coordinated planning and expertise. So we had weekly cross-team meetings, on-site sessions, and we included all of the teams in Gorenje, so for all firmware research and development and service specialists. And this was mainly only possible because we have a very trusted partnership with Gorenje. As a university, we have a 20-year collaboration, which is maybe extreme or not very common. And if I simplify very simply, is we already have the mobile phone numbers for people that we need to reach, and this greatly expedites the process compared to the traditional. So first collaborations maybe often seen in EU-funded projects. And this was clearly a very great mitigation strategy, or what they call it. So if I summarize into the key lessons learned is, so in terms of approach, I think that still the best strategy to go with is to have a hybrid approach, and you should combine AI data-driven models also with expert knowledge. And this will keep solutions and models a little bit more interpretable and adaptable. And this is also important to ensure legal compliance. So separate the technical things to the user-specific sensitive data. And the takeaway is maybe that AI isn't simply everything. Maybe combine it with expert knowledge and, more importantly, with sound logic. So maybe simple if, else if, and else sentence is in many times still a very viable solution. So another thing is that ambitious project cycles are achievable. So the project with washing machines was very ambitious. So we try to coordinate the hardware firmware upgrades and market rollout, and then the data capture and the AI training in one project. So it was almost too much. And this requires either a really good planning, but on the other hand, also very strong collaboration with technology providers and demonstrators. So if you plan ambitiously, do it on the foundations of strong partnerships and rethink supervised AI from service and end-of-life data, aiming towards that if failure labels are subjectively noted by technicians, so maybe try to be very careful. And the deviation-based learning offers a scalable and immediate alternative for predictive maintenance. So go towards the anomaly detection and avoid relying on subjective logs. And if we again, so sum it up in the best practice, not to repeat myself too much, is don't rely solely on the service logs for the AI. Do not underestimate the efforts of firmware and hardware rollouts within the project timelines, because this always comes with the delays, and these delays are often in the matter of years. Do not treat raw IoT data, especially early maturity IoT data, that they are ready for AI, because a lot of pre-processing can be involved before you can use it, and do not ignore data sensitivity and compliance issues. In the next steps, so we are basically in the phase where we just need to demonstrate the final solutions in the final year of the project. So there is no new or further developments planned for the leasing project. So the only thing we can do is so stay connected, maybe find some synergies between the projects. And if you have any questions, myself and Michal are for sure available for any discussions. So thank you very much.
Thank you. Thank you very much. I think that is a very specific but also very interesting case. Thank you. So we go on with the last project. So please, Diana, with the Restore project.
Okay, can you all see my screen? Is it in presentation mode? Not yet.
Perfect, yes, okay.
Yeah, okay. So my name is Diana Rodrigues. I'm from EWF. So EWF is the European Welding Federation, and we are the coordinators of Restore. So unlike the projects that have already presented, we have just finished our first period. So we are currently on month 21. Yes. And so we are going to focus more on general and more business model and social awareness campaigns that we are now putting in place in the project. But I'm getting ahead of myself. So before we start, just talk a little bit about the project. We have already presented this earlier. So we are actually 19 partners, and so 4 associated partners and an update 15 beneficiaries. So for the associated partners are UK partners, and it's a mix between industrial partners that produce consumables such as welding alloys, and then we have industrial partners that represent the sector, for instance, Stellantis, Navtec, and Lucchini, as well as Dalfashan. And these are all connected with the use cases that I'm going to present ahead. So, and like many other projects, they work in pairs, right? So we have the industrial partners and then some service providers or RTOs that work together. The project started last year. As I said already, it will end in 2028. We have 5 specific objectives that are very much linked with the use cases, and then more overarchingly with business models and innovation. So regarding the first one, and this is pretty much a bottom-up approach this project takes, because we start from the components and then we move up to a marketplace, to the platform. So the first strategic objective is to develop sustainable cladding processes and consumables. So, and this is welding alloys and Cranfield are taking much of the leadership around this. So by transforming the swarf from machining into consumables with recycled content. And then we move up to the digital tools for increased automation. So, and this is also, we are building up from components, digital tools that promote the increased automation in defect analysis, for instance, and simulation of the cladding. They're moving up to the processes, and now to the platform where we connect the parts, the components with the processes and the digital tools. So at least this is the idea. And with this platform arise business model innovations for remanufacturing. So, and this is where it all comes together. And this is why it's so relevant, this social awareness campaigns, that it is not so social, as you are going to see ahead. And this is what was one of the outcomes recently. And of course, then the specific objective that is linked with the demonstrators. So as I said, so there are 4 use cases. One is the rail industry with Lucchini, remanufacturing a rail axle. Then we have use case 2, remanufacturing of steel rollers with Dalfashan. And then we have Navtec providing ship propellers and remanufacturing of the propeller blades, and Stellantis with remanufacturing of automotive components. So And actually, one of the challenges also in the beginning, when the requirements were being defined, was the type of component that was going to be chosen to use in these demonstrators, and especially in the ship industry, like the size and also the type, because it needs to be scanned, how the defect analysis can be brought to the component itself. So like a lot of logistics. So this is what was one of the challenges. Also the data regarding the component at component level. Many times are data sheets that, because we are dealing sometimes with very like established industries, have their own type of data sheets and storage, and most of the times it's paper. And so so this was one of the challenges also, like the different type of data sheets for all the components, and also sometimes missing, because for instance in the case of the ship propellers, depending on the parts that were chosen, sometimes it was also not very easy to track the type of damage that they were, or the warn that they had gone through. So, but so basically, like I said, we are in the beginning of the project. We have already overcome some challenges, and we had some challenges regarding all these points that I have talked about earlier. So we have finished the state-of-the-art analysis, the failure mode and effect analysis, KPI specification for the type, for the use cases. We are closing work package 2, where Cranfield and welding alloys have successfully, for some welding alloys, developed sustainable processes and consumables. And we are now finishing the digital tools for sustainable remanufacturing. So this is very much like process optimization, post-process evaluation, tool path generation, and so on. And it has been successfully most of the times implemented, and we are now turning this into a recipe book. And we are going to enter the next phase of the project now, which is the demos and the business models and the restore platform itself. So regarding the social awareness campaign, as this is very relevant, because one of the things that has been starting to get more critical as we move forward along the project is, as someone already mentioned, so which problems are we going to solve? So what are our pains, so to speak? What are our challenges? What is the restore platform going to look like? So because there are some mock-ups from other projects, so Technovative Solutions is a partner developing this platform, but actually how it will look like and will link with the demonstrator is something that we are wrapping our heads around as we speak. And this is very important, and this is where this awareness campaign comes into play, because it kind of connects the higher levels of the project with the bottom levels of the project. So, and by listening to the industry and the experts in workshops, it will feed a lot of information on where we are going to direct our demonstrators. So we had already, so AIMEN Manufacturing is leading this. two workshops already completed, and there will be 3 into 2026. So this is also a call for action from us. And since we are dealing with the projects that are developing solutions and have similar challenges, so if you want to engage with us and help us define our way forward, this is like an open invitation. So during April and May this year's EIT Manufacturing conducted already 9 semi-structured interviews with the consortium partners, and to build up this survey that will serve as a central point to our requirements in terms of business models. The partners' needs so far, so this is a lesson that we have learned in our project in terms of partners' needs in terms of business models. We are looking for marketing and lead generation, new business opportunities with this platform, as well as connecting with like-minded companies and individuals. A lot of emphasis on awareness and education. So to actually help in the needs analysis to build up further education in terms of content and tools for remanufacturing for different sectors and industry, developing probably a system around that. And interestingly, but not surprisingly, the scope will not be citizens, but mostly industry members, academia, and customers. So yeah. So basically, the survey was developed, and it has 19 questions around the remanufacturing awareness and familiarity with remanufacturing, business viability and decision-making factors, European market outlook and readiness, and individual roles and quotas. And this is our call for respondents. So it will really help us move forward with the platform and how we answer industry's needs, and it will help us shape also the results of our project and the demos. So thank you. Yeah. Also, I believe EIT Manufacturing is also attending this call, so if you have further comments on this, please share.
Yes, so thank you. This was the last project of this kind of webinar. So maybe we can have a moment of discussion if there is some question. Obviously, each project is at different stage, but I think after this presentation that there is some similar points and similar challenge between all the projects. For example, around data quality or availability of data, understanding, for example, the use case and what are the needs of the users and the pilots. So maybe I don't know if you have some question, but we can think about some common challenge between all the projects. I don't know, or if can be some method or tools that can be combined or shared between projects that they are similar. Or for example, if can be used some platform between projects or something else. I don't know if someone has some questions or some ideas, please. Yes, please. Yeah.
Actually, I just have a question for the projects that are developing platforms. If they have any So if they could share, of course, any issues around integration and data integration and tool integration between inside the platform and how they are overcoming that.
Yeah, that probably I can maybe not answer anything for you, Diana, but because the developers of our platform are not here, so and I don't develop that, so it will be hard for me to speak about that. But if you are really interested in that, maybe we can plan a separate meeting. So I will pitch it to our partner, and then we will see if we can have. So if you send me, I guess you have my email, or maybe through Alessandra, you can get my email. And if you can send me, I don't know, a short paragraph of what you are really interested or looking for, then I can forward it to our partners. And then if it will be interesting also for them to talk about that, I can connect perfect. You, and then we can have a I don't know, shorter meeting about that.
Thanks.
Please go, Dario, if you have.
Well, yes. Regarding this, I have a more short answer, because regarding our project, we had a specific task about developing a continuous integration and deployment platform, and that was useful to help integration between different partners and components, because it also provided the guidelines, since I know that integrating different technologies and platforms, since I've been involved in many projects, it's always a challenge, and in this project it helped to have a specific task on the development and deployment of an integrated platform. That was good. And I don't know if other people has always the same experience, something very practical. The question that always emerges when we have projects with the platform, it's who is doing the UI? And no one it's ever getting that task, and how it needs to be decided at the beginning of the project, because it was not. That's a very practical thing that I always experienced.
Oh yeah, I also have a quick comment. Maybe I can supplement Michal's comment. I also do not have a full overview, because we are only involved into 2 demonstrators for the whole OADP. But what our experience is that so it is very, very hard to plan in advance the platform, because usually the platforms deals with the digital or other solutions that are developed during the project, and you do not clearly know what will be the outputs and what will be the formats of the outputs and the inputs. So what kind of streams, data streams will be going back and forth. This is very hard to plan. What we also encountered is that if demonstrators are in big established companies, so there are some very strict, so either company policies, legal policies, or other interests that prohibit that easy or standardized data collection. You must also take into account that you have, in general, maybe 4 different streams that needs to go through the data platform. One is information stream, the next one is material stream, so which probably goes in some different ways. So maybe a platform just manages the material stream, but you need transportation solutions. Then sometimes money exchanges hands. This is also difficult. And the 4th thing is, so there are legal / regionals or country specific things, also language barriers and so on, that needs to be tackled. So this is roughly my insight. So I don't have a final solution, but I'm involved in 3 projects, and these are the common points that are problematic in my view.
Yeah, so I was asking, I think we are moving towards validating those challenges in the project. Yes.
Okay. Thank you for this part. And I don't know if there is some other questions, or maybe if we can think about the exploitation and exploitable result in the market. If there is for you some points about the future of our project. I don't know if do you think if maybe some solutions can go to the market, or if you are planning something for the future, maybe we can also arrange some collaboration for the next months.
Yeah, if I may say something about it, well, in case of Restore, it's probably too early now, but it will be interesting to have some feedback when the platform is developed by the industry, or to help us also with the business model innovation around the platform. So probably I would say more towards 2028 to have some workshops around, but it's nice to have already like contacts of an ecosystem that we can reach out to. Yeah.
Yes, I think so. Okay. So please, if we don't have any other question or comments about what we have seen today, I remember you that all the registration of these webinars will be available on our channel, so in AutoTwin project website, and also in the YouTube page of AI4manufacturing community. I thank you for being here today and for this webinar series. I hope this webinar has been useful to understand what all the other projects are doing, and to learn something from each other, and to interact and think some ways to improve our work and new collaboration. Obviously, if you want, you can write to me, and maybe if you want, we can connect together, and we can arrange other webinar or training or something else. So please, if you have some ideas, we are available to collaborate together. So thank you, and have a good day.
Thank you very much, Alessandra.
Bye.
Thank you. Bye.
Bye-bye.
Thank you. Bye-bye.